So hello everyone. So in this video we are going to discuss about the topic electrostatics. So what is electrostatics? Electrostatics is nothing but electro, which means charges, statics, which means rest. So charges which are in rest position is called as electrostatics. So under this chapter we are going to discuss about few topics as well. First one, frictional electricity, and second one, properties of electric charges, Coulomb's law in vector form, units of charge, relative permittivity or dielectric constant, and continuous charge distribution. So these are the topics we are going to see under this electrostatics. So the first one is frictional electricity. So friction, what is called friction? Friction is nothing but rubbing of two surfaces or interlocking of two surfaces. So when two surfaces are up to each other, what will happen generally? Electrons will be transferred from one body to another body. In that case, some kind of frictional force will be developed on that body, and that friction is called as frictional electricity, which means the electricity produced by rubbing two bodies, and the transfer of electrons from one body to another body will take place. See, you can in this PPT I have given two examples over there. One is glass and silk, and another one is ebonite and fur. Okay, so glass. See, listen here. See the image alone. Electrons will be there in glass as well as silk, but in the electrons present in glass are loosely bound. Okay, so what will happen now? When glass and silk are rubbed towards each other, this loosely bound electrons from the glass will be getting shifted towards silk. So the glass becomes positively charged while the silk becomes negatively charged. Similarly over here, when compared to ebonite, fur has loosely bound electrons. So when ebonite and fur are rubbed towards each other, the electrons from fur will get transferred to the ebonite. So ebonite will become negatively charged and fur becomes positively charged. So this process is called as frictional electricity. So it is very important to note that electrification of the body is due to the transfer of electrons from one body to another. That is, if the electrons are transferred from a body, there is deficiency makes the body positive. Correct, no? It is very important to note that the electrification of the body, whether positive or negative, is due to the transfer of electrons from one body to another. If the electrons are gained by the body, then the excess of electrons make the body negative. Okay, if the two bodies are rubbed towards each other, the body appearing early in the list is positively charged, whereas the latter is negatively charged. So examples are for glass, silk, human body, sealing wax, amber, resin, cotton, sulfur, rubber, ebonite. Okay, so column 1 and column 2. So glass is positively charged and silk is negatively charged. Okay, and wool, fur is positively charged, amber, ebonite, rubber, plastic are negatively charged. So ebonite is positively charged over here and polythene is negatively charged. So dry hair is positively charged and comb is negative charge. So these are the things you have to keep in mind so that you can understand the electrification process. So the next topic is properties of charges. So charges. So what is meant by charge? So charge is nothing but it is the important, it plays a vital role in the process of electricity. Correct? So there are two types of charges. There are three types. One is positive, negative and neutral charge. So what is positive charge? So positive charge we call it as proton, and negatively charged we call it as electron. So neutral charge is nothing but number of protons and number of electrons will be same. So in that case we call that as neutral charge. And like charges repel each other and unlike charges attract each other. So charge is a scalar quantity. It does not have any direction, and charge is additive in nature. We can add the charges. So charge is quantized, which means electric charge exists in discrete packets rather than continuous amount. It can be expressed in integral multiples. Fundamental electronic charge, that is E is equal to 1.6 into 10 to the power minus 19 coulomb, and the value of Q is equal to plus or minus NE. N stands for integers and E stands for electrons. And charge is conserved. Okay, so the algebraic sum of positive and negative charges in an isolated system remains constant. When a glass rod is rubbed with silk, what will happen? Negative charge appears on the silk and an equal amount of positive charge appears on the glass rod. The net charge on the glass silk system remains zero before and after rubbing. It does not change with velocity also. You have to also note that it does not change with velocity also. This is one of the major point that you have to note. Okay, so we'll move to the next topic as well.